Hello 101 students. This is Ryan, here to tell you about the buffers experiment. So what are pH buffers, what do they do, and how do you make one? Well, the answer to what a buffer is fairly simple. It's a mixture of a weak acid and that weak acid's conjugate base. For example, let's take bicarbonate. This compound's conjugate base is carbonate, so if we mixed some sodium bicarbonate together with some sodium carbonate, we'd have a buffer. Easy as that. Next question, what do buffers do? The answer is in the name. They buffer solutions against pH changes. To show you what I mean, let's take some DI water and see what happens when we add sodium hydroxide to it. The water starts out at pH 6.25 and rises to pH 10.99 after the base goes in, for a pH change of 4.74 units. Now let's see what happens when we do the same thing to the bicarbonate buffer we made. The buffer starts out at pH 10.05 and rises to pH 10.14 after we add the base, for a pH change of 0.09 units. So for the same amount of base added, the buffered solution underwent a smaller pH change than the DI water. And finally, how do you make a buffer? You know part of the answer to this already. You mix a weak acid together with its conjugate base, like we did with the bicarbonate and carbonate. However, there is a little more to it than just that. More often than not, buffers need to be made to a certain pH or at least close to a certain pH. To get them there, you need to use an acid that has a pKa within 1 unit of your desired pH, and ideally as close to your target pH as possible. The reason being, the closer a solution's pH is to an acid's pKa, the closer the concentration of that acid and its conjugate base will equal each other. And having healthy amounts of both acid and conjugate base will maximize the buffer's ability to resist pH changes, regardless of whether more acid or more base is added to the solution. Once again, going back to our bicarbonate, its pKa is 10.3, so it would be good for making a buffer with a pH between 9.3 and 11.3. However, let's say you wanted your buffer to be some other pH, maybe 8.4. In that case, you would go to a table like this one and find an acid with a pKa within 1 unit of 8.4, and ideally as close to 8.4 as possible. Hypobromous acid here, with a pKa of 8.7, fits that description, so we could use that to make our 8.4 buffer with. Alright, now let's talk about your procedure. The first thing you'll need to do is turn your computer on and calibrate your pH probe. After you turn it on, your computer will need a minute or two to boot up. Once it has, you can plug the pH probe's USB cable into it. On some models, you'll plug the probe into a Go link that plugs into the computer by USB. As soon as you plug the probe in, a red box with a pH indication will appear on your screen. Use the stylus to click on it, then select Calibrate. On the screen it takes you to, select Calibrate Now. After you've done that, unscrew the storage solution bottle from your probe, rinse it off with some DI water, use a Chem wipe to get the excess water off it, and immerse the probe's tip into the red pH 4 calibration solution. Then go back to your computer, enter 4 in the value 1 box, wait for the voltage reading to stabilize, and press Keep. Next, rinse the probe off again with more DI water and immerse it in the blue pH 10 buffer. Then enter 10 in the value 2 box, wait for the voltage reading to stabilize, and again press Keep. After that, press OK to return to the main screen. Your probe is now calibrated and ready for action. When you're done calibrating the probe, rinse its bulb off with DI water, give it another wipe, and screw its storage bottle back in place. Trust me, you don't want this thing to dry off. Next, you're going to make 2 buffers. These have to be made to a certain pH. Your TA will tell you what this pH is when you get to lab. To make your buffers, you'll be provided with 3 different solutions of acid and their conjugate bases. Your job will be to choose the most appropriate acid and its associated conjugate base to make your buffers with. When you go to do this, remember what we talked about earlier regarding the relationship between acid pKa and the pH of the buffer being made. Both your buffers will be made to nearly the same pH, so you'll use the same acid and conjugate base for both. To make your buffers, you'll mix your chosen acid and conjugate base together in 2 different ratios. One buffer will have a little more acid, the other a little more base. You can use a graduated cylinder to measure out the acid and base solutions you use. Once you have your buffers made, add a few drops of universal indicator to them. This is a dye that will change color depending on what pH your solution is. After you've made your buffers, you'll test them to see how well they resist pH changes. You'll do this by determining how much sodium hydroxide and hydrochloric acid you have to add to cause them to change a certain number of pH units. You want to do this as precisely as you can, so you'll measure out samples of your buffer with a pipette, and measure the sodium hydroxide and hydrochloric acid with a burette. If this is the first time you've used either piece of glassware, see the links in the description. They'll take you to another video with some tips for using them. And that's it for your data collection. When you're done, make sure to dispose of all solutions in the lab room's waste container. Also make sure you've drained all solutions out of your burettes and thoroughly rinsed them with DI water. When you're done rinsing your burettes, leave them with their valves open.